Okay, so, and when you're approaching a confidence interval problem, there's two types of measurements that we're trying to estimate within a population. So like we're going out and say we want to find, we're healthcare workers and or maybe we work in an insurance company and we want to know what's the average lifespan of an American male, right? So we want to know what's the average age that they live, right? So we take a sample of the population because it's impossible for us, when you say American male, that includes millions of people, right? So we're not going to be able to talk to and look at every single person. So we take a representative sample, right? And the measurement we're after is an average, it's a mean. So the first thing you want to look at as you're approaching these problems is what is the population measurement we're making, or what is the population parameter that's being measured. A parameter is a number that describes an entire population, right? So you have parameters, which are numbers attached to populations, and then you have statistics, which are numbers attached to samples. So like for a population proportion, we represent that with the P. It's a number, a percentage, P is a percentage, that describes a population, like 30% of whales in the Puget Sound are orcas, right? Something like that. So it's a percentage. But what we're after in this case is a population mean, an average. And so that a parameter representing mean is given by this symbol, the mu. All right, you're familiar with all that. Okay, so as we're approaching a problem, as you approach a problem in the homework, you want to go, wait, okay, so are they talking about estimating a population percentage, or are they, are we estimating a population average or mean? Okay, if it's a percentage that we're after, so we want to know something about the percent of people within a large population or things, then we're always going to be using Z for our critical value. Okay. Now there's some, for our purposes, we're always going to be using Z, but there are some parameters we have to meet in order for that, for us to be able to do that. But for all of our cases, we're gonna, the problems you're going to be presented with already meet the parameters, so you don't have to do, you don't have to test. But basically, n, so your sample size times p has to be greater than or equal to 10, and n times its complement, 1 minus p, also has to be greater than or equal to 10. But again, this will always be the case for our problems.
Okay.
But as long as this is met, then we can use Z. And so the functions for Z, you know, if you're using your calculator, that would be invert norm or normal CDF, right? Those are functions on your calculator that go with Z. Invert norm, anything that says norm in it, normal CDF, NCDF. All right, if it's a population mean though, that we're measuring, so we want to know something about the average of a population, we have to ask a second question. So this is our first question here. Here we have to ask a second question, and that is, what is the source of the standard deviation that we're working with? Because all the formulas with means involve a standard deviation. The proportion measurements don't have, they don't quote you a standard deviation. The standard deviation is found by a sort of a different formula within their formulas. But with population means, we always have to know what the average spread is in order to calculate margin of error and hence confidence intervals. So what we're interested in is how did they get the number that they're quoting you for the standard deviation? Was it from the population? If it was a population standard deviation, then they use sigma. But if the numbers that they used to come up with the standard deviation came from a sample, then that standard deviation you're being quoted is a sample standard deviation, because the source of it was not the entire population, but rather just a small portion of the population. So it's a sample. If it's a sample that was used to calculate the standard deviation, then this is when we use T. And if it was the entire population that was used to calculate the standard deviation, then we can use C.
Okay.
So there's only one path really where we use T. Oops. Oh, that's a race. I was trying to do a highlight. I don't know if they have that option here. At any rate, this is the only path here where we're testing for a population mean, and the standard deviation we're using comes from the sample that was taken. And so we're going to use T. Now, in all of these confidence interval problems, remember that we're trying to estimate a population parameter, either a P or a mu, and we're going to take a sample. So it's not about whether the word sample appears in the problem. Because for either of these, for whatever scenario we're doing, there will be a sample taken. The question is, was the standard deviation calculated from that sample, because the population standard deviation was unknown? Right, so it's specifically the standard deviation you want to hone in on. If it's T, then of course we always will use, if you determine at the very beginning, and this is something you want to kind of map out at the very beginning of each problem when they're all mixed together like this. Hold on 1 second. There's somebody else coming in. As you're kind of approaching the problem, you want to read it really carefully and kind of at the beginning decide, is this a Z situation or is it a T situation? And then whatever you're doing, whether you're using your chart, right? If you're using the T chart, then the T values are up in the big body of the chart. And then the Z's are at the very bottom, at least at the chart I sent you, the one I had posted there. Hi, Rika.
Hi.
I'm finishing up. Which class are you from?
I'm from 96-140.
Okay, great. I'm just helping a stats student right now with a couple of questions, and then I'll get to yours if you don't mind waiting a minute.
Yeah, that's fine.
Okay, great. Thank you. Okay, how can I go back to my screen? Okay, so you got this. Let me see if I can get to WOM app. I can share the screen on my computer. Okay, so it's in the middle of answering somebody's question here. So I'm going to go to one of the problems here just to kind of look at it for a minute. Here goes my dog. Okay, so if I go to this problem, for example, here on question 3, out of 400 people sampled, 328 had kids. Based on this, we want to construct a 90% confidence interval for the true proportion of people with kids. All right. So on our chart, the first question asks, what is the population parameter that we're measuring? And we see, oh, okay, this is a population proportion. And so because it's a proportion, we're going to use the Z for all our stuff.
Okay.
And of course, the proportions have their own formulas, right?
Right.
We have our mean formulas, and then we have our proportion formulas. So I'm going to go back to here. Oh, shoot. Let's see, stop my share here. Go back and forth. Okay, so, you know, for proportions, the margin of error formula is my Z value for your given level of confidence multiplied by the square root of your sample proportion multiplied by its complement and then divided by n. And you have to be careful as you're entering these into your calculator too. If you have an older calculator, when you do the square root, I'm not sure which one you have.
I have the TI 84 Plus, so it's relatively new.
Yeah, but even the pluses sometimes have this old programming where if you go square root, it gives you a parenthesis, and then you got to type everything. So let's say we were using 75. So I would go 75.75 times, and then I can use a parenthesis there, go 1 minus 0.25, or I could just, or 1 minus 0.75. Or I can just type 0.25 because it's just the complement. And then you have to hit divided by, and then 400, let's say, was our sample size. And then close it. So you got to be careful about closing your initial parenthesis there. This parenthesis, when I opened up a new one here, I closed it here, but you don't want to close the parenthesis of the initial one until you've got everything you want underneath the
Oh, okay.
Yeah. And in the newer ones, there's no parenthesis, but this thing just keeps extending, right? So you kind of know what's underneath it.
Right.
Yeah. So anyway, just be careful.
Yeah, mine doesn't do the parenthesis unless I put it in myself.
Okay, great. So you have it's a little easier to see. And then once you want to get out from underneath the radical, you just hit the right button and it takes you out from underneath it. Yeah. So you have that for proportions is your margin of error. And then whatever your margin of error ends up being, we're going to take the sample proportion. We're going to add that margin of error and the sample and subtract that margin of error. That gives me the lower boundary and upper boundary of my interval.
So
Also,
in this situation, the 400 would be my sample proportion?
That's your sample size.
Sample size, okay. And
Yeah.
the proportion is the 0.75?
Well, whatever it was 380
right.
something, you know, over 400.
Okay.
So whatever this is, and if it's a proportion, I recommend if you're going to put it as a decimal, take it out to like 4 places.
4 places? Okay.
Yeah, at least, because WAMAP can be really picky in that.
And that's what I'm finding is a couple of times I've gone through and then somewhere, because I'm trying not, I don't do rounding until the end, but I'm still finding that sometimes it's off by something minuscule.
But a lot of times that's due to either the T or the Z being, if you use, you know, because T's and Z's a lot of times will be very close in value. And so a lot of times that's what is throwing off people's answers. And they think it's just WAMAP, but it's actually, it's not that. It's that they're using the wrong T or Z. Let's see, so we have margin of error, and also the minimum sample size is another one with proportions, where we have to go p hat times 1 minus p hat with the Z over error squared. In your default, you probably saw this in the video, the default p hat value, if they don't give you one, is 0.5. So if they give you an estimated p-hat value, then you're going to use that. Hey, come here. But this is the minimum sample size formula, right? And then for means, the margin of error is either z or t multiplied by either sigma or s over square root of n, right? And it's, as we saw in that chart I gave you at the beginning, it's z if we're working with the population standard deviation, and it's t if we're working with a standard deviation derived from the sample. But otherwise, the formula itself is the same. And the minimum sample size, z times sigma over e squared. Yeah, so the formulas are different, right?
Okay.
Completely different. Like my margin of error formula is not alike at all, except it's the, you'll notice the, it's the critical value multiplied by the average spread of that size sample. And that's what we have here too. It's the critical value multiplied by the average spread of samples of that size. So it's kind of like if you can picture the normal curve, right? We're saying, well, here's where my sample fell. So I'm going to go a little bit to the left and a little to the right based on the behavior of samples of that size, right? And their average spread, how they differ, because samples will differ. And we can be 95% confident that the real number for the population is somewhere between here and here.
Okay.
Yeah. Does that, I don't know if that helps.
No, that helps.
The first thing is probably the most important one. When you're doing a practice, figuring out, okay, is it a proportion? Is it a mean? Okay. And if it's a mean, then you ask that second question. So before I kind of let you go, and I'm gonna, let me see, do this again. I'm gonna pull up another example real quick. Okay, so here's another one. Assume a sample is used to estimate a population mean. They're always going to say that at the beginning, right? We're trying to estimate a population proportion, or we're trying to estimate a population mean. So here we know we're on the other side of that choice path, right?
Okay.
We're trying to estimate a population mean, mu, as opposed to proportion, like our previous one. It says find the margin of error that corresponds to a sample of, if we take a sample of 13 and we get this mean from it, and we calculate this standard deviation, and we're going to use a confidence level of 80%. Okay, so notice here's the description, because the next question we have to ask is, what is the source of the standard deviation we're being given to work with? And here it doesn't call this number 6 point, here we know this is my standard deviation, right? 6.5, but it doesn't directly tell us, is this a S or a sigma? Is this a sample standard deviation or is it a population standard deviation? But if we read and look at the context, it says that we took a sample of 13 and we calculated this mean of 46.6 from it and a standard deviation of 6.5. So the standard deviation of 6.5 came from this sample we took of 13.
Okay.
Right? So in the context, it's like, hey, we went out, we took a sample of this many, we calculated this number, and then we calculated this number.
Okay.
So because the source of that calculation was this sample of 13, that makes it, by definition, a sample standard deviation, S. And so we would want to use T on this, because the source of the standard deviation is this sample of 13.
Okay.
Does that make sense?
Yes.
Okay. So as you go through and have you run out of time on this particular assignment?
I did both of these assignments. There was the homework 12, I think, and then there was a reading assignment that was 63 questions. So I used a late pass Tuesday going into Wednesday. And then last night I ended up completing another 10 questions, I think. But I still have questions left in both of those. So I did run out of time.
In this homework, the general confidence intervals?
Yes.
Okay. Let me go ahead and I'll stop sharing here. I'm just going to extend that out till tonight so you can continue working on this, okay?
Okay.
Because it's really important to go through this, and I think you may start to get a little more confidence in your confidence intervals.
Okay. Yeah. I'm just a little worried that I'm going to be so behind with this week.
Yeah.
And we're so close to the
one
end.
thing at a time. One thing at a time.
We're so close.
You'll be fine. Because this, once you kind of get this down, that process, going into the next stuff is going to make it that much more like, oh, okay.
Right. And that's what I'm finding. Like last week's content was, once I got it, I was totally okay with it.
Yeah.
But then back to binomial distribution, that one was a disaster. And that's where I'm feeling like I'm drowning again with this one. So
yeah. Well, what I was going to say is the big thing you want the first two videos are the most important, 12.1 and 12.2, which are going into hypothesis testing. Because it's there that you really want to get into the mentality of what we're doing.
Okay.
And kind of lay that foundation. And then you can start getting technical about, okay, Z in this situation, T in this situation, but it's the same criteria. That diagram I gave you, it's the same criteria.
Yeah, the diagram is really helpful because when I'm done here is I'll go in and draw one out and then make it a little more clear and then use it to just follow along.
Yeah. And what's nice about the stuff you're going to be doing for Friday is that it's broken up in just like your first few confidence intervals ones were, where it's like all Z here, all T here.
Right.
These are all proportions. And then just like last week, this next week, you'll be working on throwing them all together into one assignment, the general hypothesis testing.
Okay.
For those things.
All right.
All right.
Well, we'll see what happens.
All right. Good luck. Let me know. I mean, post questions that you have, and I'll be looking at that as we go.
Okay. Sounds good. Well, thank you so much.
Thank you.
Okay. Have a good day.